The question for this video is plus 1. Given a non-empty array of decimal digits representing a non-negative integer, increment 1 to the integer. The digits are stored such that the most significant digit is at the end of the list, and each element in the array contains a single digit. You may assume the integer does not contain any leading zeros except the number 0 itself. The constraints for this problem are the length of digits lies between 1 and 100, and each individual digit lies between 0 and 9. Let's start by understanding what the question is asking of us. Let's say for an input array 3417, what this denotes is the number 3417, or simply as 3 is the most significant digit and 7 is the least significant digit, it will be 7 into 10 raised to the power 0 plus 1 into 10 raised to the power 1 plus 4 into 10 raised to the power 2 plus 3 into 10 raised to the power 3, which will of course give 3470. The question is asking us to return the array for 3417 plus 1, which will give 3418. So our returned array will be 3, 4, 1, and 8. Similarly, for a number like 32499 or 32,499, we know the next number is 3,200 32,500. Therefore, the returned array for us this time will be 3, 2, 5, 0, and 0. Therefore, what we have to do is we have to take the number from the array, add 1, and return the new array. Now, let's start off by thinking of the most basic brute force solution for this problem. The simple brute force solution here is to find the integer itself by doing the process we did in the previous window, which is 9 into 10 raised to the power 0, the first element, plus the second last element, 9 into 10 raised to the power 1, plus 2 into 10 raised to the power 2, plus 9 into 10 raised to the power 3, plus 3 into 10 raised to the power 4, plus 4 into 10 raised to the power 5, which will at the end give 439,299 or 439,299. Then we'll add 1 to this number, which will return 439,300. And at the end, we will return an array which contains all of these values, which is 43930, and of course another 0. So what we can see here is we will be adding 10 to the power of the last element 0, then 1, then 2, and so on. The problem with this method is the length of an array can be up to 100. So last element will be x raised to the power into 10 raised to the power 99. And this will exceed any integer or long range you have available. So it will not be able to store it in the memory. And also, as the power is very high, the amount of computation also is very high. Therefore, we need to think of a more optimized solution for this. To start thinking of an optimized solution, we'll start by thinking how addition really works. So for a number 7369999, if we add 1 to this number, what we'll get is here 9 plus 1 will give 10. So we'll carry over the 1. Then again 9 plus 1 is 10. So again we'll carry over this 1. Again this 1 plus 9 will give 10. So we'll carry it over. Again 10. And this time we get 7. And as there are no carryover, 3 and 7 will be written as is. So what we can see here is that the last digit, that is 9, starting from the end, and the first digit, which is non-9, are the only numbers which will be affected in this range. The rest of the numbers will go down as they are. That is because only when 9 plus 1 is equal to 10 is the next number affected by the addition of 1. If the 7 plus 1, for example, if the last number is 7 plus 1 gives 8, this does not affect the next number as there is no carryover. This leaves us with the case that if all numbers are 9, then if we add 1, of course, the numbers will continue to carry over, and at the end we will have one extra 1 left over here. Therefore, the answer will be greater than the number of nines here, the number of zeros, and then plus 1. What this shows here is that all we need to calculate is the answer for the ending elements, which are 9. So we'll continue iterating from the end of the array up until we find a non-9 number. And if all the numbers are 9, we will need to add an extra element to our answer, which will be a 1 at the beginning of all the zeros. Now, this is our code for the previous algorithm. Initially, we'll have the value of carry as 1 is being added to the array. We'll start I from n minus 1, that is the last element, and we will check if this last element is equal to 9. If it is equal to 9, we will make this element equal to 0 and we'll continue on. And the value of carry will still remain 1 as 1 has been carried over from this 9 to the next number. Otherwise, we will make the value of ai equal to a of I plus 1 if a of I is not equal to 9, that is. And we'll make the carry 0, as even if the a of I is 8, this a of I will now become 9 and it will not affect the next element. And we'll break out of the loop. If carry, this is the condition for if all elements are 9, that is, it never went inside this else condition and never made carry equal to 0, we'll have to add 1 to the beginning of a. As we do not know what the size of a will be, as if all elements are 9, the size of a will return will be n plus 1. And if all elements are not 9, the size we'll be returning will be n size only. Therefore, we cannot use an array for this algorithm. We will need to use a vector in C++ because we need dynamic memory allocation. Let's see how this code works for the given array. So for the given array, initially our carry will be equal to 1. So we'll start off with I equal to n minus 1, which is 5. As this element is 9, it will go inside this if condition, and this element will now become 0 and will carry on to I equal to 4. Again, a of I equal to 9, so we'll change the value of this element to 0. Carry will still remain 1 as we have not gone inside the else condition. And the next element would once again be 9, so we'll change the value of this to 0. And now for the next element, a of I will be equal to 4, which is not equal to 9. Therefore, it will enter the if condition where a of I equal to a of I plus 1, carry is equal to 0, and will break the loop. So 4 will become 4 plus 1, which is 5, and will break out of the loop. So our final condition for the array will be 3, 8, 5, 0, 0, 0, and we'll return this as our final answer. Now let's run it for something which has all 9s inside of it. For example, 9, 9, 9, 9. Now here, it will always go inside this first if condition. So all the elements of this after our for loop will become 0. That is 0, 0, 0, 0. And now if carry, that is carry is not 0, therefore it will go inside this if condition. We'll add 1 to the beginning of the a of a, which is now a vector, as we cannot utilize an array for this because we need dynamic memory allocation. So our final answer will now become 1, 0, 0, 0, 0, and we'll return this as our answer. This is the algorithm mentioned in the previous question. We'll see how it works for example of an input array 429999. So initially our carry will be equal to 0, and then next we'll go into digits. Its digits of I is less than equal to 8, that is it is not equal to 9. We'll add digit plus 1 and then we'll make carry equal to 0 and break out of it. Else if this number is 9, we will make it equal to 0 and carry will stay as 1. So initially we'll start off with with digits of size -1, which is n minus 1, that is the last element. Therefore the last element is 9, therefore we'll make this element equal to 0 and we'll continue next. So after the first operation, the array becomes like this. For I equal to 4, then again this element will be 9. So the array in the next step becomes 429900. For I equal to 3 and I equal to 2, similar steps will follow. So the array at the end of I equal to 2 becomes 4, 2, 0, 0, 0, 0. Now here, as this element is not equal to 9, we'll go into this first if condition, that is it is less than equal to 8, and we'll make it equal to 3, which is 2 plus 1. So our final array here will become 4, 3, 0, 0, 0, 0 for I equal to 1. Now we'll make carry equal to 0 and we'll break out of the loop. If this carry had not become 0, we would have added digits dot insert at the digits beginning 1. That is, if all numbers were 9, this if condition would be satisfied and this would have returned 1, 0, 0, 0. And now we'll return this digits vector. As I mentioned before, vector here is being used because we need dynamic memory allocation. We don't know if we'll be returning a vector of size n or of size n plus 1. Also, here the time complexity is big O of n, as we're using one loop which runs from the end of I digits from n minus 1 to 0. The space complexity here is big O of 1. We're not using any auxiliary space as we're editing the vector given to us as input. If initially our input is given as an array, we would have to use a vector and create one ourselves. Then the space complexity will become big O of n, as we have created an auxiliary vector which has n or n plus 1 elements. Similarly, if asked in an interview or in a test said that this initial vector given as input is immutable, we would have to create our own vector to find the answer, and the space complexity again in this case will be big O of n. Also, the insertion here also is also done in complexity big O of n, as we have to move all the zeros to the right side and insert one at the beginning. Now we'll try and submit this code on LeetCode. So we'll run this code and see if it gives the correct output for the sample testing. It does give the correct output, so we'll now submit our solution, which gives success in 0ms. So the idea here is to not store the integer as a variable from the array, but to keep on increasing the value of the array from the end if the value is 9, and will continue carrying over 1. If all elements are 9, we will add 1 to the beginning of the array and the rest of the elements will be 0. Otherwise, this for loop will come to a stop at the first element from the end, which is not equal to 9. It will increment that value, and after that, all values will be equal to 0. And before that value, all values will stay the same, which will give us our final answer. And we'll return this in a vector.